Greetings, this is Ryan Benton, Caitlin Leone, and Caitlin Bland here from Dr. Park's Accounting 301 class, Intermediate Accounting Part 1, and we're about to demonstrate question number 2 of the Chapter 6 homework. Now, Dawn Corporation is contemplating the purchase of a machine that will produce net after-tax cash savings of $20,000 per year for 5 years. At the end of 5 years, the machine can be sold to realize after-tax cash flows of $5,000. The interest is 12%. Assume that the cash flows occur at the end of each year, and our objective is to calculate the total present value of the cash savings. Now, question number 2 is an ordinary annuity. An ordinary annuity question has two separate parts. First, we want to find the present value of the $20,000 annual payment. And to find the present value of the $20,000 payment, we're going to use a formula. That formula is, starting with the numerator, 1 minus the product of 1 over 1 plus I to the nth power. Now the I represents the interest rate, and n represents the number of annual payments. We're going to divide all of that by I, which again represents the interest rate. So now we have plugged in our numbers, 0.12 representing the interest rate, and 5 representing the number of annuity payments. So using the rudimentary order of operations, first we want to find the sum of the two numbers in the parentheses, 1 plus 0.12. So 1 plus 0.12 gives us 1.12. So we plug in 1.12. Now, next step of the order of operations is we want to find that to the 5th power. So we already have 1.12. Find that to the 5th power, and we get 1.76234. So now we plug in 1.76234. So now we want to find the product of 1 over 1.76234. Okay, so we want to find 1 divided by 1.76234 equals 0.56743. So now we compute 0.56743 into our formula. So now we want to find the difference between 1 minus 0.56743. 1 minus 0.56743, and we get 0.43257. So now all we have to do is find the product of 0.43257 and our interest rate 0.12. So we want to take 0.43257 divided by 0.12, and we get 3.60475. So we're going to use this number and multiply it by our annuity payment, which is $20,000. And so we take 3.60475 and multiply it by 20,000, and we get 72,095.
Now, mind you, there are some slight errors in rounding, so it's give or take $1 or $2 or pennies and such. Also, to take note, Ryan meant divide by instead of multiplication.
Okay, now that concludes the first part of this question. Now let's move on to the second part. Now in the question it says that at the end of 5 years the machine can be sold to realize after-tax cash flows of $5,000. What that tells us is at the end of the 5-year annuity duration the machine can be sold for $5,000. So what we want to do now is we want to find the present value of that $5,000. And in order to find the present value, we're going to use a slightly modified formula from our predecessing question. Now, this may look familiar to you. This was actually a portion of the formula we used in the first part of our question. So we have 1 divided by, parentheses, 1 plus I, close parentheses, to the nth power. Okay, so now we plug in our numbers. You'll recognize the interest rate and the number of annuity payments. So we'll just go through our rudimentary order of operations, starting with the sum in the parentheses. So 1 plus 0.12 gives us 1.12. We want to find that to the fifth power, and we get 1.76234. So now we want to take 1 and divide it by the denominator, which is 1.76234. And we get 0.56743. So we want to take our present value of $5,000 and multiply it by 0.56743. And we get 2,837. So now we take 2,837 and we add it to the answer in the first part of our question, which was $72,095 as the present value of the $20,000 annuity payment. So we add 2,837 to 72,095 and we get 74,932. Okay, well that's a wrap. I hope this helps. This is Ryan Benton, Caitlin Leone, and Caitlin Bland saying so long.